Okay, here I'm going to provide a systematic data-driven review concerning COVID-19 in schools. Now, all sources provided on each slide, it is mentioned with direct links. Also, in the video description, there is a link to the slides for easy viewing and downloading to allow you access to those links. The basic summaries are children are at reduced risk from dying from COVID-19. Children are poor transmitters of the virus. And do not just read the headlines, look at the actual data and research studies. High COVID areas tend to match high population areas as well, and we'll see a map of that. Now, deaths in COVID-19 related to age. Well, COVID-19 deaths increase directly with age. What this means is the older you are, the higher risk of death from COVID-19 you have. Under the age of 14, and really potentially under the age of 24, the odds of death from influenza or pneumonia are greater than COVID-19. And what pneumonia is basically fluid filling the airspace in the lungs, reducing the amount of oxygen that can get to the blood. And if that oxygen becomes too low, that will result in death. Here's just a kind of combination of leading causes of death in general, broken apart by different age groups. This provides not just diseases, but other causes of death based on 2016 data, with the higher causes of death being located at the top, lower ones at the bottom, influenza and pneumonia in kind of these orange boxes, and COVID-19 in the blue boxes there. This is the actual CDC data website that you can provided here at this link that you can go to and access. What it is, I took this data, I was able to download it as an Excel file, and this is what I generated directly from that data set we just saw. This just makes it a little easier to read, and it's looking at February 1st to August 8th for the United States, broken apart by age group, allocating COVID-19 deaths, pneumonia, influenza in total. I then took this data and compiled from the age of 0 to 14 and put the COVID deaths, pneumonia, and influenza deaths for comparison between the ages of 25 to 24. And in both of these age groups, these are your typical school age children, pneumonia is of greater risk of death for people under 24 years old based on the CDC data. Looking here at data from the American Academy of Pediatrics, they stated at this time it appears that severe illnesses due to COVID-19 is rare among children, and they have some information current as of August 13th, 2020 here. What is interesting of note is that children were 0% to 0.4% of all COVID-19 deaths, and 20 states reported 0 child deaths. Now, taking this information, the definition of a child does vary by state, so it makes it a little hard to do some comparisons. However, the greatest age range for the definition of a child is Tennessee and South Carolina, and they state from between 0 and 20 years old is a child. However, using the CDC data that I showed, I'm going to add in from 0 to 24 and consider that a child, which technically is going to overstate cases or deaths, but it's going to be used for the comparison here. Well, the cumulative child cases is 406,109. Total child deaths, and again, I'm dividing a child as from 0 to 24, would be 291. The child mortality percentage is 0.07166. And if we look at the United States cases versus mortality percentage, based on Johns Hopkins University presented by CNN, you're looking at that math comes out to 3.135%. So you can see the child mortality percentage is much reduced. Now, what about risk to teachers, since we are talking about schools? For those that have to work with students, and the concern is the ability to contract COVID-19 from students, while the students may be at low risk of COVID-19, what about students' ability to transmit the virus? That's a great question. The possibility of carriers and at-risk populations comes down to the degree of transmissibility. Children have been shown to be poor transmitters of COVID-19. And we're looking at the data provided here and source down here. What does this data actually show? So to what extent do children transmit the COVID-19 virus? It's a great question. The evidence to date suggests children spread SARS CoV-2, which is the COVID-19 virus, relatively rarely, and that children are usually infected by symptomatic or pre-symptomatic adults in the first 48 hours before they become symptomatic. In conclusion, based on the study here, the available evidence to date suggests that children are unlikely to be major transmitters of SARS CoV-2 or the coronavirus that has caused causes COVID-19. And again, there's the citation, the links, and everything provided there for you. So what about an article like this that was in the news? If you're at this age, you're most likely to infect loved ones with COVID-19, and I provided the kind of quotation here from this article. They quote the emerging infectious diseases, and I went to that source, and you can see that here. So up at the top here is the link provided to the Best Life article, and then down here is the link to the actual study. Well, the age groups, and this is the data table too, their age groups are consistent every 9 years, which is great to see. If you look at the numbers of contexts in which the percentages are calculated from, because this study is focusing on percents. Well, in the 10 to 19 age group, it's based on 231 participants. However, the next age group up, the 20 to 29 age group, is based on 3,417 participants. So while it's great to compare percentages, does this really make a fair comparison when there's a 14.79-fold increase in participants between the two age groups? So this is why it's important, again, to look at the data instead of just quoting percentages. Where did those numbers come from? Now, what could be contributing to why children are such poor transmitters? So we mentioned before that they're poor transmitters. Well, why would this be? What's the potential explanation for this? And some highlights here provided in this study are that asymptomatic non-coughing people release less virus-loaded aerosols to begin with. Children have less alveoli and terminal bronchioles where breath droplets are formed. And those are interior components of the lung. We kind of see them here. They look like a cluster of grapes, and they create a high surface area to allow gas exchange. But children have less of them. Children also have lower respiratory minute volume and tend to have lower viral loads. All of this combined can explain why children are poor COVID-19 virus spreaders. Now, when we're looking at confirmed COVID-19 cases in the United States, we often see maps that look like this. And while maps like this look clean and are easy to read, the state's borders are man-made. However, this isn't easy, recognizable, and does translate the state-by-state data into a visual very easily. However, a more accurate description than this, where we're looking at actual borders and changes, would be something that looks more like this. And what this is above me is the tracking of COVID-19 cases in the United States. You see how the bubbles, the bigger the bubble, the more cases. But we also see in comparison, I pulled the 2016 US population, and we see a lot of similarities, indicating that where we're finding a lot of COVID cases are simply where there's a lot of population. If we pick one area out in particular, the Hawaiian island of Oahu, we're looking at the increased population. Well, sure enough, of comparison to the other Hawaiian islands, it has increased COVID-19 cases. So again, just take this into comparison when you're looking at states that look like this. For example, Montana looks really large here. It's a very large area in state, but relatively low population compared to other areas such as California or the Northeast, where states might be small but very population dense. In the United States, people are living longer, and this is a positive. But in regards to COVID-19, it does mean more people will be in the increased risk category. We see the demographics here of male and female in the shift over time, comparing the census data from the year 2000 to 2010. Now, if we look at deaths by cause in the world in 2017, I'm not going to bore you with all the details here, but you can see clearly cardiovascular diseases is number one. Respiratory disease is very high, and that includes and breaks out lower respiratory infections as well, being very high normally, and COVID-19 falls into that category of being a respiratory disease. So they're naturally high, and this is just looking again at 2017 data. What's interesting of note is malaria, over 619,000 deaths in the world in 2017. Now, probably didn't hear a lot about this, particularly in the United States, because there are only about 5 deaths reported annually in the United States, mostly from return travelers, with only about 1,500 cases. So it's important to remember we have to think about things in a worldwide perspective. And if there's things that can be, resources that can be applied to potentially cure or definitely reduce the risk or death rate of certain issues, that is definitely something that should be considered. Keep in mind that malaria is a mosquito-borne disease caused by a parasite, so a little different than COVID-19. But again, we must be thinking about more than just one single country. We must be looking at the entire world and where can we try to make reductions in causes of death.